Howdy everyone, this is Boone, and today I'll be going through how to do U.S. Coast Guard problem 467 when the height of the tide, you're trying to find the time, and you are given the amount of feet you need to account for. The last problem I covered, in the last video, I covered problem U.S. Coast Guard problem 557, and in that, I said I would be doing 607 in my next video, but I would have to delay my last because 607 is very, very similar to 557, and I really think if you know how to do 557, you can easily do 607. But 467 is almost an easier version of both those problems, so I'd highly suggest checking out the last video, as this is part 3 in I guess the 3-part series regarding high of tide problems. So the problem you're looking at is 467. It's a one sentence problem where it says, at what time after 1400 EST ZD plus 5? Now, if we remember from the first 2 videos, ZD plus 5 is a meridian we want. This is the meridian we want to account for, so this is good. On January 4th, 1983, will the height of the tide be at Port Wentworth, Georgia, at 3 feet? Okay, all good information. Let me tell you what all that means. So, I bring up my paper. The date is 4 Jan UARY 83, just like every other problem. The time desired is after 1400 EST. This is not a daylight savings time. Okay, now that we know that, and the ZD checks out, I'm gonna go down to the bomb. And you know how we did on the last problem? We had a formula that we used to find the required height, or the actual depth of the water. Well, now we are given the actual depth of the water. 3 feet. Then the high tide at this time is 3 feet. So what we're solving for is this box right here. Now remember, we will be able to find all the information from here to here, except for this box, which is the time from the nearest tide. Okay, now that we have all that, all of our given information, let's go back to the tide reference table and plug in what we know. So Wentworth, Georgia. So let's copy that and bring this to the reprints. So in the reprints, we're gonna paste this without the comma. And it has 3 things that show up: Port Wentworth, Georgia, and Port Wentworth. And this is a an F, so we're not going to be using that. So we're going to go through it again and push enter, and then we can see that this is the Port Wentworth that we are trying to find. Now that we know that it's the Port Wentworth, we need to copy down, like we've done for the past few problems, the daily predictions. So this is going off the reference station of Savannah, and this is subsection 2715. Like I said in the last one, this is simply just a number. It is good to know, but not necessary per se. Since this is Savannah, all right, write that down, and it's on page 104. That's a big piece of information. Really doesn't matter what it's called. We just need to know what page it's on. So I'm simply going to be copying down the height differences that it gives us here, which is plus 00 hours, but 33 minutes, plus 00 hours, 41 minutes, and height difference is minus 0.4, and low water is 0.0. Perfect. So now that we have all that, we've completed the first part of the page. We're going to go down to table 1, where we're going to find all this information. So it says Savannah is on page 104. So let me go back to the reference. And we're currently on page 100. So as you can see that this is page 224 in the Coast Guard book. It doesn't really line up. So let's just go until we find it. right section. So we're 163, 109. We're looking for 104. Okay, so we're close. So this is in January. It should be right on this page. Yep, here it is. So January 4th, 1983 is a Tuesday. So let me zoom in on that real quick. And let me enable my again. So perfect. All right. So now that we have this, let me copy down the information from this box right here. There, that's really good. That. Okay, so we're trying to find after 1400. So after 1400, we're looking at 12 and 19. So since we're not accounting for daylight savings time, they're going to be 12:47, just how it appears, and 19:19, just how it appears, with 7.8 and negative 0.4. Remember, we are not ever using this column right here. That will mess you up. In fact, I will cover it up so you don't even have to get confused. So now that we have this information, we need to account for the information of Wentworth, Georgia, that we are trying to solve for. So let's see, 12. So this is high water, so we're going to add in the high water. And here's my calculator, which you are allowed to use. 47 plus 33 is 80, minus 60 is 20. So it would simply be 1320 because we need to add an hour. 1919 plus 41, 19 plus 41 is 60, and 60 just adds another hour, so it would just be 2000. Now we need to account for the low water. Low water height difference is 0, so it would simply be negative 0.4. And the high water height difference would be a minus 0.4. So that make this 7.4. 7.8 minus 0.4. 7.4. Makes sense. Okay, cool. Now, if you have any questions on any of this, please don't feel to reach out or write in the comments or however you want to get in contact with me. I will be glad to answer any of these questions up to this point. Just let me know what part of the video you are concerned about. Okay, now that we've gotten to this, we need to do what we've done in the past problems, and we need to subtract 2000 from 1320. We need to subtract both of those. 19, 60, 60 minus 20 is 40. 19 minus 13 is 06. So 06 hours, 40 minutes. Apparently what we're doing with a duration of rise or fall between these two numbers. Range of tide, 7.4 minus a negative 0.4, which is 7.8. Height of the nearest tide. Now this is what we need to do these two for. We did this in the last problem. So we have L and H. L simply means we're taking 3 and we're subtracting the low water. 3 minus 0.4, 3.4. High would be 7.4 minus 3. Now, whichever one of these is lesser, which would be 4.4. Whichever one of these is lesser is the one that is going to be closest to use for the problem, which would obviously be L, the low water. Now that we have that, 3.4 is also our correction. Table 3, 3.4. And the height of the nearest tide is low water, and that would be negative 0.4. Makes sense so far. Okay, so now that you've probably got notes down for that, we're going to write out to the side 2000, because 2000 is low water, which is the closest one, and negative 0.4. 0.4 plus 3.4, which is the correctional factor, will net us 3 feet, which we are looking for. Now that we have this all here, we need to then find what the time difference is to get us the correct time. We're in the last stages of the problem. But the last stage requires us using table 3, like we have used for every other problem. And if you do not have a printed copy of this, I highly, highly, highly recommend it. Can't tell you how much I recommend it. Alright, so let's pull this out to the side and use table 3 right now. So the range of tide is 7.8, so we're going to round that up to 8. So we're going to go over here, and we're trying to find 3.4. The 3.4 is right between those two. So you could either interpolate or simply just use the, I don't want to say correct one, but the one that Coast Guard is looking for. By definition, since we were never specified if we should interpolate, I'm going to be honest and say I don't know how you are supposed to correctly navigate this situation, but we're between these two numbers precisely. So what you're supposed to do is go up to 253 and 207 because your range is 640, so 253, 307, 40. We found that on the other part. So it should be 3 on the spot, but the correct Coast Guard answer requires you using 307. Now, if we were doing this for a test or quiz, I would have to say that this would have to be accounted for. If we would have to be told to interpolate, or if we were told not to interpolate, we'd have to be told which one to use. This is too much error to leave up on the student alone. So I will make those remarks known to our chain command soon. So, but we're going to to get the correct answer, we're going to be using 307. So we come back over here and we put in 0307 and we subtract. When you subtract, because you're trying to get the closest to 1400 you can. Oops, you can't see that. You get 16, 53, 19 minus 3 is 16. So at 1653, the height will be 3 feet. And we're going to mute my camera. We're going to go back over to here, look at the additional problems. Correct answer, 1653. Thank you for watching this 3-part series. This has been actually a decent amount of fun explaining this over the internet. I hope it has been of some help to someone out there trying to do these problems. These problems are not the hardest. They're simply just a little confusing on their work. I hope I've cleared up something for someone. And please reach out to me at my Academy email or on Facebook, either one. If you need any, I'd be really glad to help. Or if you're somehow got this link and you're watching this from another maritime school, I would also like to help you. Thank you again. I'll catch you guys next time.